All right, here we are with problem number 2. Okay, so we need to figure out the area of the shaded region. Okay, so there's 2 areas that you have to find. Okay, you have to find the area of the triangle. Okay, and by doing this, you gotta know what kind of triangle you're dealing with. And so, if you think about it, this is actually a 30, 60, 90 triangle. Okay, and remember, across from the previous problem, across from the 60 is x squared root of 3. So, and across from 30 is x. So this is obviously 5 square root of 3 on the bottom. Now I have to double that, okay, to get 10 square root of 3 to get the whole side measure of that triangle. All right, and then we also need to find this radius for the circle. Okay, remember it's double whatever 5 is. Okay, it's 2x this side, right? So it gives you 10 for the radius. Okay, but we're going to use our we're going to use what we just found. Okay, so I'm going to get the area of the triangle, but we're going to use your polygon area for it. So it's 1/2 AP. Okay, our A is 5. So we're going to go 1/2 times 5 okay, times the perimeter of the triangle. Okay, so if you do the perimeter of that triangle, it's 10 square root of 3, okay, times 3 sides, which gives you 30 square root of 3. Come back here. Sorry. Which gives you, okay, which gives you 30 square root of 3. So I'm going to plug in 30 square root of 3. Okay, so when I multiply that out for the triangle, I get 129.9. Okay. Now, I need to do the area of the circle. Okay, most of you guys should know what the area of a circle is by now. It's pi r squared. Okay, so the area of the circle is pi times the radius squared. Well, the radius is 10, so we're going to square 10. Let me erase that so it looks better. Okay, so you're going to go times 10 squared. Okay, so pi times 10 squared. So 100 times pi, that gives you 314.16. Okay, so you're looking for the shaded region. So in the end, all you're going to do is subtract the 2. Okay, so we got to get the area of the shaded. I'm kind of running out of room here. Okay, so area of the shaded. Okay, I'm going to write into this bottom problem, so I apologize. Is 314.16 minus 129.9, and so you get a grand total of 184.26. Okay, so that's how you do that problem. Just get the area of both, and then at the end, subtract. Okay, moving on to the next problem. Find the area of the shaded sector. Okay. I've given you guys kind of a formula for this. It's kind of on the formula chart I've given you, but it goes, okay, X is the shaded region we're looking for. over the area, pi r squared, of a circle, equals the number of degrees, okay, over 360, okay? So this isn't that hard. All you got to do is plug in the information here. We don't know what x is. We know what r is, so we're going to go x over pi times 3 squared, okay, equals the number of degrees, 95, over 360. Okay, and then from there you're going to cross multiply. Okay, so you get 2686.06 equals 360x. Okay, so I got to divide by 360. And x equals a grand total of 7.46. And there you go. You just found the area of that shaded region. Okay. All right. Now from here, I'm going to have to erase everything. So sorry about that. Okay, so the next problem, actually I just have to erase this problem up here. Okay, so the next problem, okay, it wants to find the arc length. Okay, so your arc length is this part right here, because it's part of that shaded portion. Okay, so I'm going to take 360 and I'm going to subtract 132. And when I do that, that's going to give me a angle or arc measure of 226. Okay, and then from there we're going to do kind of a similar equation from before, not exactly the same, but almost the same. So I'm going to do x, that's what we're finding, over 2 pi r. Okay, remember arc length is a part of circumference. Okay, and I'm going to put 226 over 360. Okay, so when I do this, I'm going to cross multiply. Okay, remember to plug in r. R is 11, so I'm going to write 11 over that r. Okay, so right now we have 360x equals, okay, and then you got 226 times 2 times pi times 11. That gives you 15,619, I believe. 15,619. I'm going to divide by 360. Okay. And I get x equals a grand total of 43.39. Okay. So there are your first four problems on your review. Okay, I'm going to continue on for some of the other ones here. All right, here we are in question number 5.
What?
They are wanting you to solve using your 30, 60, 90 triangle. And so what I'm going to do is I'm going to redraw this 30, 60, 90 part. Okay. Actually, I don't even need to do that, but I want you to label the sides. Okay. Across from the 30 would be x. Across from the 60 would be x squared of 3. Across from the 90 would be 2x. Okay, and then from there, okay, it tells you PT right now is 4. Okay, so there, from there, I'm going to now plug in which x is 4. So from here, I'm going to plug in 4 for x, okay? So from here, I'm going to go 4, square root of 3. for that side, and then for the other side, I'm going to make it 8, okay? Because it's double 4. And so now what they want is they want VT, and if you look over at VT, it's right here, okay? VT is 4 square root of 3, okay? PV, okay? PV is 8, okay? So there you go. That's how you do that one, okay? So now I'm going to erase those answers, okay? And now I'm going to do the second part, okay, using those numbers. Using those equations, okay? And so from here, I'm going to say PV now is 100. So I'm going to go here and put 100. Well, that's equal to 2x, okay? So when you think about it, 2x equals 100. What is x? Well, you divide it by 2, okay? And x equals 50 when you do that. So now I go over here on the triangle. I say x equals 50. And over here, with the x squared root of 3 side, I'm going to put 50 square root of 3 in its place. And so now when they ask you for PT, you can say now it's 50. Okay. And then for VT, it is 50 square root of 3. Okay. So that's how you do the 30, 60, 90 triangle. Let's go on to the 45, 45, 90. Okay. Remember the other angle on the 45, 45, 90 is 45. And so across from the 45s is x. Okay. And across from that 90 is x square root of 2. Okay. So from here, I'm just going to put in the information that they give me. And so they say AB is 7. So we go here. This is 7. Well, if AB is 7, then this other side that has x is 7. And then that longest side of the triangle is 7 square root of 2. So now when I plug this in, I go over and I say, well, AC, I know what it is. It's 7 square root of 2. Okay. And then when I do CB, it is 7. Okay. So pretty simple. Now I'm going to do the next problem. Okay, so I got to erase all those numbers that I just did. Okay. Okay, I'm going to rewrite x here and x here. Okay, and it says, well, BC is 8. So I'm going to go over here and put 8 for BC. So the other value that's x is also 8. And the other side that we're missing here, okay, is 8 square root of 2 because x is 8. So now when I go to plug this in, it says AB. What is it? It's 8. And what is AC? It's 8 square root of 2. Okay? So fairly simple. Okay? If you know your sides of your 45, 45, 90, and 30, 60, 90, these should be fairly simple problems. Okay, so here we are in number 9 and 10. Number 9 is a mid-segment problem, and all this line is it is half of, okay, this line right here, okay, is half, okay, this line is half of this other line. Okay, so there's two ways I can look at this. Instead of saying half of that line, I could also say 2 times the mid-segment is equal to 3x plus 7. And I think that's the easiest way to think about it. So I would think 2 times the mid-segment, well, the mid-segment is 17, okay, equals that bottom line there, the parallel line, 3x plus 7, okay? So it's easy to multiply 2 times 17, it's 34, okay, equals 3x plus 7, okay, and then this is just basic algebra. You should know how to do this by now, so minus 7 from both sides, okay, so 34 minus 7 is 27, equals 3x, divide by 3, okay, and x is equal to 9, okay? So not a hard problem. Just got to know your rules about mid-segments. Okay, next one. You are given a regular octagon, okay? Regular, don't forget, means that all sides and all angles are congruent in that figure, okay? So what is the sum of interior angles, okay? So you got to remember these formulas. Sum of interior angles formula is n minus 2 times 180. Okay, and remember, n represents the number of sides. So all I'm going to do now is I'm going to go 8 minus 2, which is 6, times 180. Okay, and when you do that, you get a grand total of 1080. A pretty easy problem. Just got to plug in the number of sides. What is each interior angle? So we're going to still take that same exact equation, n minus 2 times 180, and I'm going to divide it by the number of sides. Well, I know that n minus 2 times 180 is 1080. Okay. So I'm going to take it and divide it by the number of sides, or n, which is 8. Okay. So if you think about the formula, it's n minus 2 times 180 divided by n. Okay, that's what you would use for B here. And 1080 divided by 8 is 135. Okay? Alright, so fairly simple. Okay? Now I'm going to erase these right now so we can get a little bit more space here. Okay, so let me erase that. But hopefully you guys got that. Oops. That's what I want. Okay. All right, so now it says the sum of exterior angles. So when you think about all the exterior angles for every regular polygon, it doesn't matter what size it is or how many sides. Okay, if it's a regular polygon, it's always going to be 360 degrees when you add them all up. Okay, and then so if we do each exterior angle, okay, for this octagon, I'm just going to take 360 and I'm going to divide it by the number of sides. Okay, so the number of sides, obviously, of an octagon is 8. So 360 divided by 8 gives you 45. Okay, so pretty easy stuff. Just gotta be able to do it. Okay, thanks. So here we are doing some trigonometry. Okay, with these some of these questions here, and the main thing you got to remember is there's an acronym. Okay, the acronym is SOHCAHTOA. Okay, and SOHCAHTOA, the S represents sine, the O represents opposite, and the H represents hypotenuse. So you got sine, opposite, hypotenuse. Okay, those kind of go together, so that goes together. Okay, cosine, okay, cosine is cosine, adjacent, hypotenuse. Those go together. Okay, let me use a different color here. Okay, and I'll do purple. Okay, so those go together. Okay, and the last one here, okay, is TOA, is tangent, opposite, adjacent. Okay, and these are kind of ratios to help you solve for the missing sides or the missing angle. Okay, so first thing I'm going to do, okay, so I'm going to go over here, and all you want to do here is they just want the ratios here for 11, 12, and 13. So they're giving you the reference angle. The reference angle is angle C here, okay? And so from angle C, I'm trying to do cosine, okay? So I go over to my SOHCAHTOA saying here, and I say, well, cosine, you have to have an adjacent side and a hypotenuse side. Okay, so if I look at C, okay, the adjacent side, adjacent meaning it's next to that angle, okay, well, there's two numbers that are adjacent really to C, but remember, the side that is across from the right angle is your hypotenuse no matter what. Okay, so now that only gives me one option. For the other side would be 3 here, and that would be your adjacent side. And so I'm going to label the side so I know what sides I'm picking for the ka part of SOHCAHTOA. So right now it's 3/5. Okay, so that's my answer, 3/5. And you always make sure you can reduce these numbers, but 3/5 obviously is reduced. Okay, so tangent, okay, so now I'm going to erase that part, okay, so now I'm going to go over to tangent of A, that's my next reference angle, okay, and I don't need the adjacent now, so this is going to change every time you change your reference angle. So A, I'm looking at tangent, well I go over to SOHCAHTOA, I look at tangent, tangent is opposite adjacent, so I go opposite, well opposite it, okay, opposite that would be 3, okay, and it says adjacent. Well, I can't use the hypotenuse because even though I know it looks like it's adjacent, so my next option is I got to go to, okay, to 4. So right now I have opposite adjacent, and that's the order I go when I write my fraction. So I go 3/4, okay, and then now I'm going to erase that again, okay. And so I'm going back to my reference angle as C again. And so from here, okay, I am going to use sine, and sine is opposite hypotenuse if you look at the SOHCAHTOA saying. So the opposite side, nice and easy here, is 4, okay. And so the hypotenuse would be, okay, 5, okay, so when I do opposite over hypotenuse, it is 4/5, okay, and so that's how you do that problem, just to do the ratio part. So here we are with question number 14, okay, so now they need to solve for the missing side, so I'm going to look at the reference angle, and the angle that they give me is 29. Now, I don't pick the 90 because it's not your reference angle. Your reference angle is the other two angles that they, that is not 90. So 29 would be your reference angle here because that's the one they give you. Anyway, so I'm going to look at the sides compared to 29. And so I look, and x is opposite 29. So opposite would be the first thing I put. And then I look at 14. Well, some of you might say, oh, well, it's adjacent, but if you look at it, it's across from your 90-degree angle, so that has to be the hypotenuse. All right, so right now I have an opposite and a hypotenuse, okay? So when I set this up, I go to SOHCAHTOA and I say, well, I got an opposite hypotenuse, I got an O and an H here, so I'm going to go to sine, okay, and I always put the angle measure next to sine, okay, equals, all right, and I'm going to put the opposite over hypotenuse because that's the way order it says. This is OH, right? So opposite is X, hypotenuse is 14, okay? And then this becomes like a cross multiplication problem, okay? So you're going to cross multiply. Well, X times 1 is X, okay? 14 times sine of 29, okay, is what you write. Okay, and so that's the way you're going to plug in your calculator, and make sure your calculator is in degrees when you do this, okay? So 14 times sine of 29 gives you 6.79, okay? All right, so that's how you do that problem. And pretty much the rest are kind of like this. You're going to use your reference angle, for example, number 15. I look at where X is compared to it. Well, X is adjacent to it, not opposite. Okay. I'm going to write adjacent. Okay. And then 17 would be your hypotenuse. And from there, I'm going to look at SOHCAHTOA and notice that adjacent hypotenuse is cosine. So I go cosine for 24, okay, equals adjacent over hypotenuse, which is x over 17. Okay, put that over 1, cross multiply. So I get x equals 17, okay, times, okay, the cosine of, 24. And so when you do that, you get a grand total of, when you plug it in, 15.53. Okay? Fairly simple. Calculator does most of the work. Just have to set it up correctly using SOHCAHTOA. Okay? I'm going to erase some of these so I can have some space for 15. So I'm just going to erase this. Yeah. So, okay. So I want to be able to calculate angle A and angle C. So this is a different type of trig problem where now you're solving for the angle. So let's go one at a time. Let's say I put x here. Okay. So if I wanted to solve for x, okay, that's my reference angle. I look at the sides compared to x. So opposite here is 9. Okay, so I have an opposite side. And I look at this one, I have an adjacent side. Okay, so now I look, I'm like, well, I got an opposite and adjacent. So the only one that has that is tangent. It has an O and an A up in the acronym. And so I'm going to go tangent of x, okay. And I'm going to put the numbers opposite over adjacent, so which is 9 over 5. Okay. And then from here, I need to do the inverse, okay? So when I do the inverse of this, okay, on my calculator, all I'm going to do is I'm going to press the second button, and I'm going to press the tangent button. So I'll go second tan, okay, so this becomes the inverse. All right, I'm going to plug the fraction in the place of where x was, and that is going to give me what x is, okay? And so when I do this on my calculator, I'm going to get, for angle A, I'm going to get 61 degrees. Okay, so let's say x is 61, okay, really, which is really the measure of angle A, okay? And so now I'm going to go to the other angle, okay? And let's just call this one y. So I'm going to erase all that other stuff, okay? So that way we don't get all confused. Okay? And I'm going to do the same exact type of problem now, but I'm using a different reference angle, okay? So C now is your reference angle. Now look at the sides compared to it. So opposite is 5. Oops. Okay. Adjacent now is 9. Okay, well, that still is tangent, so I'm going to go tangent. Now, let's say we'll call it angle CY. Okay, so tangent of y is equal to, now it's going to go opposite over adjacent, which is 5 over 9 this time. Okay, so when I do that, again, I'm going to do the inverse, so I'll go second tangent on my calculator, and I'm going to plug in the fraction where y was. Okay, and it equals y. Okay, so let me see, tangent, the inverse tangent is 29 degrees, so y is equal to 29 degrees now. So I end up getting 61 for A, 29 for C, okay? And if you want to double check, go ahead and add 61 plus 29 plus 90. It should come out to 180. If it doesn't, then we probably did something wrong, and then we gotta go back and check, okay? Anyway, so that's using SOHCAHTOA, okay? Using it to help you to solve your trig problems. Okay. All right, here we are on 16. Now we're going to get into circles.
I would suggest there's a little formula chart that I've kind of given you in the past, and I'd suggest using it to help you see which formula to use for these. Okay, but let's see if we can get number 16 going. First one here, 16. I noticed that the arc right here is 256. Now, if we think about a whole circle is 360, okay? So I'm going to go 360, okay, minus the 256. And what that's going to do for me, okay, is it's going to get me this other arc on the other side, because if you notice that there's a central angle right here, and that angle needs to match up with that arc, okay? So 360 minus 256 is 104, okay? So this arc is 104, and your rules of central angles is the central angle is equal to the arc. So that 3x plus 14 is equal to that arc, which is 104, okay? And so when I solve this, it's just regular algebra now. I'm going to subtract 14 from both sides. Okay, I get 3x equals 90 divided by 3. X equals 30 degrees. Okay, and so just be careful. Sometimes they want you to plug it in for x. So just keep that in mind. I might be plugging 30 back in to find out what 3x plus 14 is, maybe. Or in some other problems like the next one, they may want you to find what the angle measure is. Okay, so next one. This is an inscribed angle problem. So the rule goes, the angle is equal to half of the arc. Okay? So if I look at this, I know that 20x is the angle, is equal to half of the arc, which is 140. Okay? So from here, I go 20x, I go half of 140, which is 70. Divide that by 20. And that gives me x equals 3.5. Okay? All right, so pretty easy. Just know your inscribed angle rules, okay? Next one, I would probably use that formula chart that I've given you in the past. You should be able to recognize, but your job is to multiply all these numbers that are along the same segment together. So I'm going to go 3 times x plus 12 equals, and I'm going to do the other one. So I'll go 5 times 4x. I'll go 5 times 4x. Okay? So now if you multiply that out, okay, 3 times x, and then 3 times 12. So I get 3x plus 36 equals, I'm going to do the same thing, 5 times 4x, which is 20x. Okay, subtract the x's. And so I get 36 equals 17x. Okay. And then from there, you're going to divide by 17. Okay. So you end up getting x equals, now this one's not going to come out pretty. Okay. Give me a sec, I just got to calculate it out. Okay. And where's my calculator? All right, so when you divide, you get 2.1 about. Okay. All right, so the next one, another picture you need to look on your formula chart and recognize, but if you look at these two tangents here, both tangents that connect out there in space are equal in value. So 4x equals 2x plus 6. Okay, so I'm going to subtract 2x from both sides. I get 2x equals 6 divided by 2. X equals 3. Okay. So fairly simple problems, just got to find the formula. Okay, next one. Okay, so I'm going to erase this part. Okay, that way we can have a little bit more room. Okay, so now I'm going to do this one. If you look at the formula chart, you're going to notice that the two arcs added together, oops, sorry, 72 plus x, okay, divided by 2 equals that angle in the middle there, which is 63. Okay? And so when you do this, all right, you're going to use your reciprocal rule, okay? So I'm going to multiply both sides by 2, okay? By this, that gets rid of the 2 on the bottom, so that gives me 72 plus x equals 63 times 2, which is 126. Okay, I'm going to subtract 72 from both sides. And that's going to give me x equals 54. Okay, so that's your final answer. X equals 54 for that. Okay. All right, number 21. Okay. 21 is dealing with special segments. I'm going to erase this real quick. But right now you're looking at a perpendicular bisector. Okay. And with a perpendicular bisector, okay, it splits the bottom part here into two congruent parts. So this is kind of the midpoint. It bisects it. It has two right angles, okay? And then if it does that, it splits pretty much these two sides right here have to be congruent, okay? So now I'm just going to say 5x equals 4x plus 3, okay? And so all I'm going to do is subtract 4x from both sides, and so I get x equals 3. Okay, so fairly simple problem. Just got to know a little bit about special segments, but should be fairly easy. Alright, so here's another problem you have to kind of find on that formula chart. And so I'm going to take this tangent here, one that's all by itself, and I got to square it. And the next one is a secant. The way secants work is you take the outside, which is 2, you multiply it times the whole thing, and so you got to add 6 and 2, which gives you 8. Okay, so 2 and 8 is 16 right here, and then to get rid of something squared, you got to square root it. Square root of 16 is 4. Okay. Now, next one, I want you to find the volume and surface area of a sphere. Okay. All right, so the volume, okay, of a sphere, okay, is 4/3 pi r cubed, okay, and so I'm going to go 4/3 times pi, okay, times the radius. So if you look here, they give you the diameter, the radius is 3, okay. So I'm going to go 3 cubed, okay? And so when I do that on my calculator, I cube something, okay? So 3 cubed becomes 27, okay? I'm going to go 4/3 times pi times 27, okay? And now I'm going to multiply that out, okay? And you can leave this one either in terms of pi or just multiply it out, but you get 36 pi, or multiply it out, it's 113.1, okay, inches cubed, okay? So pretty simple. Just got to look up the volume formula for a circle, and then the next one is surface area. And so if you look that up, it's 4 pi r squared, okay? And so when I do that, okay, 4 pi times 3 squared, okay? And 3 squared is 9. 9 times 4 is 36. So that gives you 36 pi, okay? And get the same answer, actually, as the one before, 113.1. But now this is inches squared, okay? So sometimes they come out the same. You never know, okay? Next problem, okay? I'm going to try to split this, okay? It says find the lateral and total surface area of a cylinder if the radius is 5 and the height is 12. Now you could draw a picture, or you don't really need to draw a picture. You just need to plug it into the formula. So lateral surface area here is 2 pi RH, okay? So I go 2 pi, the radius is 5, and the height of the figure is 12. So a lot of this information just given right to you. I'm just going to plug it right into the calculator, and I get 120 pi. Okay, whoops, 120 pi. Okay, and if you leave it, that's if you leave it in terms of pi, but if you multiply it totally out, you get 376.99 inches squared. Okay, so that's right there is your it's your lateral. Now I'm going to do a total surface area, okay? And so the total surface area includes your lateral, which is 2 pi RH, plus the other part to it, which is the two circles on the top and bottom, which is 2 pi r squared, okay? And so when I do this out, I already have lateral, which is 120 pi. I'm going to add 2 pi times 5 squared, okay? So 5 squared is 25 times 2, which is 50. So it becomes 120 pi plus 50 pi. And if you leave this in terms of pi right now, it would be 170 pi. Or if you were to multiply it out, you would get 434.07. Okay? Inches squared. Okay? So, not a hard problem. All you had to do is plug it in. Okay? So I'm going to erase this. Okay? So I can have some room for the next problem. Okay, I'm going to erase a little bit of that too. Okay? So this one says to find the total surface area of a rectangular prism whose base is 3 feet by 11 feet and then it is 19 feet high. So it might help you just to draw a picture if you need it. Okay. You should know what a rectangular prism looks like by now. Okay. So if you label the dimensions, it's 3 by 11 on the bottom. Okay. And then the height is 19, okay? So it wants the total surface area. And so the total surface area, okay, is pH plus 2b, okay? P represents the perimeter of the base. So we look at the perimeter base, okay, the dimensions are 3 by 11, so 3 plus 3 plus 11 plus 11, or you could do 3 times 2 and 11 times 2, okay? And so that gives you, you do that 44, I believe, 3 and 3 is 6, and 22, let's see, 11 plus 11 is 22, plus 6, okay, no, sorry, I'm wrong, that gives you 28, okay, for that part, okay? So you get 28 for the base, okay? And so the height of the figure, okay, is 19, okay, plus 2 times the base area, Okay, so if we use the base area, it's 3 by 11. So B equals 3 times 11, which is 33. Okay, so let's put this all together. And so I get 28 times 19, 532, plus 2 times 33, which is 66. Okay, so we got plus 66. That gives me a grand total of 598 in the end. Okay, there's your total surface area. All right. Okay, so next problem. So here we are with number 26. You want to know the surface area of a pyramid, okay? And so, surface area of pyramid, okay, is 1/2 PL plus B, okay? And so when you do this, the perimeter of the base, okay, P is 14 times 4, okay? And that gives you 56. Okay, and you're gonna have to know what B is. Okay, so B is the base area. So you're gonna go 14 squared, or 14 by 14, and that gives you 196. Okay, and then you need to find out. And so in order to find out, I got to use Pythagorean theorem because this is a right triangle in here. And so I'm going to split 14 in half, which gives you 7. Okay, and so when I do this, okay, I'm going to go 7 squared plus 24 squared. Let me write that better. 7 squared plus 24 squared equals C squared. So when you solve that all out using Pythagorean theorem, okay, that gives me 625 on the left side here equals C squared, square root it. So C equals 25 when you do that. So that gives me L is 25 on the picture. Okay. So now my L equals 25. Okay, so all you got to do now is plug it all in. So I go 1/2 perimeter of the base, which is 56, times L, which is 25, the slant height. Okay, plus the base area, which is 196. Okay, and you put all that together, you get a grand total of 896 yards squared. Okay, not a bad problem. Just gotta know to use Pythagorean theorem to find L. Gotta know how to get the perimeter of the base and the area of the base. And just plug it all into the formula, and it's not a bad problem. Okay, next one, I'm going to erase a little bit of this. That way it doesn't get all mixed into the next problem. Okay, and so right now they say quadrilateral BCJK is a rhombus. Okay, if measure of angle CBJ is equal to 32, then what is JBK? Okay, so we got CBJ is 32, so I'm going to mark it off on the picture. It's 32. Okay, and they want to know JBK. Well, diagonals split the angles into half on a rhombus. So the other side, this is an easy one, is 32. So answer is 32 degrees. Okay, list the properties of a parallelogram. Okay. So some properties of a parallelogram, okay, that you need to know. You gotta know about the opposite sides, okay? Okay, are congruent, okay? Opposite sides are parallel, that's why it's a parallelogram. Okay, this is a parallel symbol. Okay, the two lines going diagonal like that. Okay. And another important part, you need to know that the diagonals bisect each other. Okay. I could list a bunch more, but these are just the main ones that you really need to know. Okay. All right. Pretty simple. Okay. Next one we're going to go is now 29, list of properties of a rhombus. Okay. And for this one, I am going to erase a little bit of that. Okay. And so the first property I really want you to know. Okay. Some of the parallelograms carry over here. So opposite sides congruent. Okay. Opposite sides parallel. Okay. Diagonals bisect each other. Oops. I'm a horrible speller. There we go. Bisect. Okay, each other. I might be going into the other problem on this one. Okay. Diagonals bisect angles. Yeah, I'm still bad at spelling. Okay. Canals bisect angles. And the last one that you need to know, that's very important, is diagonals and I keep forgetting the A when I spell. Okay. Diagonals are perpendicular to each other. Okay. So that means they create right angles when they cross. All right, so just some things you need to know. Going into the final here is some of these properties. Okay. All right, let me erase some of that now. See what we can do number 30 here. Okay. All right. All right, next one says, determine the number of vertices, edges, and faces for a square, pyramid, and triangular prism. Okay. All right, so even if you do a square pyramid, you can even draw it. Okay, you draw a square. Okay, you can dot up there. Okay, so if you were to count the vertices, okay, it'd be 1, 2, 3, 4, 5. So 5 vertices. Okay. Next one, faces. Faces are flat surfaces. So you got 4 triangles. That's 4 flat surfaces in the bottom. So that would give you 5 faces. Okay, and then the edges. Okay, edges are the lines that connect to the corners. So if you think about, it's 1, 2, 3, 4, and then you got 4 in the bottom. So 4 and 4 gives you 8 edges. Okay. So that would be to a pyramid, and let's now look at a triangular prism. Okay, so I'm going to draw myself a triangle prism. Okay. And there we go. So let's look at the amount of vertices. So it's 2 up top, 2 down to left bottom. So 2, 4, I would say 6 vertices. Okay, faces. 1, 2, 3, 4, 5. So I got 5 faces. Okay. And then I'm talking about now the edges. Edges are the lines that connect corners. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 3, 6, 7, 8, 9. So I got 9 edges for that one. Okay, just double checking. All right, so probably your best bet is to draw a picture here. Okay. All right, so let's move on to the next problem. Here we are in the last two problems. You're dealing with a quadrilateral, that's a rectangle here, and just got to label the sides or what they want you to label. In this case, the first problem wants you to label parts of the diagonal here. So this is 2x plus 4, okay? Give me a sec. Okay, so that's going to be 2x plus 4, and then Zn would be 20, okay? And so remember that the diagonals of any type of parallelogram, or in the rectangle in this case, it's going to bisect the diagonals. So really simple problem here. So I'm going to go 2x plus 4 equals 20. Okay, minus 4. 2x equals 16 divided by 2. X equals 8. Okay, so x equals 8 for that one. Okay, now this next problem does nothing to do with the previous problem, so we got to erase. Okay, I'm gonna erase all that. Okay, so now it says ln, the whole thing is 8x, and the other one is a different color. Okay. Hey, what's up? The whole thing is 4x plus 12. I'm helping people solve problems on their exam review. Yeah. Okay, so right here I'm going to set them equal. The diagonals are equal. Okay. Equals 8x. So minus 4x from both sides. 12x equals 4x. Shh, sweetie. Shh.
Hey, hi.
Hi. So divide by 4. Okay. Let me redo that.
What are you doing?
Divide both sides by 4, and you get x equals 3 for that one. So.
Yeah.
All right, so that's it on the problems. Hopefully this helps you out for your final exam. Thank you.